Okay, super excited for this one because I got this to work a few times, and of course it's not going to work on camera just because. But the main thing we're trying to do is understand what's in front of us and act accordingly. So now what I have going on is I have a model looking at what is the object in front of us, how should we grasp it. Not only how should we grasp it, but is it delicate? Does it require firm pinching, like if we want to grasp just a little bit of the cloth? And most people would do some form of imitation learning to make this happen, but not me. No, not me. I want to pick up this orange. This is an orange, and this orange is actually a light wheel orange. And I don't know why I just grabbed it so hard. Why did it do that? It had it the first time, but it had it and then went to re-grasp it for whatever reason. Not exactly what I wanted to happen, but Gemini told it to grab it more firmly, even though I said not to grab it firmly. So that's obviously not a successful trial, and I've had a few, so we'll just sit around and we'll get one more for sure. After Gemini realizes it doesn't have the orange in its hands and it squeezed a bunch of juice everywhere. This is very interesting because I have tried this with an orange with the open arm, and it works just fine. So you just have to be pretty delicate, and it will actually do it. It's a little slippery, but that's the joy of this, is we want to do what we do as humans. We want to, of course there's two grippers, and we actually have like a friction-full material on our fingertips, to keep that grip. If we wanted to grab, say, an orange slice with two fingers, we could. But for this gripper, first of all, it's not grabbing. It is grabbing in the correct location. That I've tuned very well. It's pretty impressed with that. But what it's not doing is, you see here when the orange is finally still, it's already decided where it's going to grasp it at. It's going to overshoot because the orange was somewhere else when it started looking. And then it's going to look down and correct itself. And why it's moving so slowly now is it's identified this is an orange. And of course, I could write some code that says, move to your normal waypoints until it's time to get to the gripper movement, but I just wanted to see everything moving even slower. So I just said, hey, if this is a delicate object or if it's deformable, just move slower. Now, that's something that I did. Certainly it could move to that waypoint much faster and then execute the number of waypoints much faster, and then get to this point where it successfully grips or not success. So we'll see. And what I have running also in the background is a little bit of collection on what went wrong. So it'll kind of, as it's about to grip, it takes a photo of what's going on. It also looks at all the things that it's been told to do by the system, by both Gemini and my code. And let's see, so it squeezes here, but then for whatever reason, it just and then loosens when it already has it. So that's, and sometimes it works, sometimes it doesn't. I don't know where, I'm going to chase down where this code is, but you can see here, we're moving about 50-50 on that. When it had it the first time, it didn't understand why I let it go, but certainly my imitation learning data will correct this behavior. What I wanted to have happen, and what is happening, is that I now have multiple objects and basically the entire catalog from Lightwheel that can be picked up by the open arm, as well as any other assets that I decide to find that look somewhat sim-ready. I'm going to bring them in here, and I'm going to execute picking up the orange. So I have the full orange, the half orange, apples, strawberries, and I want to just try these various objects, and then I'm going to move on to clothing pinching, which that is going to be tricky and challenging, but I want the system to do this. I don't want to do any of it. Like, yes, I want to collect some data and my data is going to be better than what the system's capable of collecting. But the diversity of objects, I want to be able to say, for every object that's a SEM-ready asset in the entire world, I want to create a set of instructions that is also generative. So let's say it's filling the teapot or the coffee, coffee that has the filter paper. It's got a bunch of little steps. I want all those steps to come from generative AI. Yes, in a few times we're going to, give it some invitation learning data for one coffee pot, but we can't do this for every coffee pot that will have a SEM-ready asset. So that's what I'm trying to do is go through the list of SEM-ready assets with however many robot embodiments as I can get my hands on that are physically accurate. And by the way, I have my fully running CAD to URDF pipeline to USD pipeline running. So that's another cool thing I got going on. But let's see if we can go 2 out of 3 would be cool. That second grasp, I have to chase down the code and figure out what's going on there. But because it gets it the first time, and I think maybe if I had dropped some tactile sensors on this gripper, which I don't have in real life, so I don't want to put anything in the simulator that I don't have on the robot. But, it might make some sense very shortly to put some tactile sensors on the simulator. Yeah, because right there, it should have just grabbed it and held it and just kept it. Now it squeezed it, see? And then it fell off. So that second grip wasn't ideal, but I'm not going to do 20 trials because I feel like we can fix that second grip. It's kind of somewhat ridiculous. We have to figure that out. I haven't fixed it yet, but I had a thought. Ideally, we want we have the D blocks, we have the 3D representation of the orange. If we can send that to Gemini or whatever else we're using, send it to Gemini and say, this is the 3D length, width, and height of this thing, and generatively decide on how much to pull the gripper in. I think that would be an ideal situation. This way, what you can do is say, all right, I have this thing, I want to apply this much force, with the grippers, and then if I have fingers, I want to apply this much force to each finger, and I want to move this finger to this location in order to grasp the object the way we want to grasp it. I think that would be, the solution. So let me try that, and I'll come back. So a little time later, it was actually just like one line code change. So I tried to have Claude Opus look for the problem, and it went off into space, and was coming back with some really odd answers. So I just looked, and there was really like one line that said, okay, if we verify the lift, basically, if we are not sure we have it, open up and regrip. And that totally works if we're not sure we have something. But if it's not like vital that we have it above, because obviously we don't want to not have the thing and then not wholly, and it's slipping and then it drops and breaks. We don't want that. But for certain objects, I'm going to enforce like certain grip styles, and that's just something that we can already do if you're using Move It, or there's so many grasping policy generators out there. But I'm going to do mine generatively. So the point here is to just let the models work through its own problems. So what I've done is created this kind of round trip that does like 40 trials, and it says like, all right, we have success for 10 of them. What was wrong? And then let the code work itself out. Eventually this will be a completely closed loop with human in the loop if I really want to. That's the problem right there. You see, it grabbed it, and then it just like, I gotcha. Like, that's wrong. And so I need to work out why that's happening. Yes, we have success here, but it just did it again. And I'm really trying to understand, when it has the object, why does it do it again? Why does it regrasp? And maybe there's some deeper code. Maybe I'll let Claude, work out the situation. But as you can see here, this is probably a successful video, 10 minutes long. It's probably a lot. But you can see that there it is. And our next steps are to try a bunch more objects with the right hand. And then we're going to try a bunch of objects with the left hand and make sure everything is copacetic there. And then we're going to try, first, I'm going to do a few imitation learning passes on two-handed objects. So basically doing something with both hands, or bimanual manipulation. I'm going to do a few imitation learning passes on it. But just to see what happens, I'm going to ask Gemini to pass a block from one hand to the other and see what happens. Once I have both hands, both grippers truly 100% figured out. I'm also working on, I've tested out a bunch of robotic hands, including hands from my friend Rob Knight at the Robot Studio, now Uma. I've tested out a few hands from him. I've tested out the X hand, a few other hands that are escaping my memory right now. And I'm going to settle on a hand to actually 100% pass my code base along and make the hand better than any hand is on the internet. I believe I can do that. Just with the system that I've already built, and that's not being egocentric. It's just a matter of I've done this in simulation already. So what's rolling right now is that the hands or arms or grippers are somewhat training themselves. There's not enough sim-ready assets, or at least I don't have access to more sim-ready assets. I need really good deformable bodies. Like the solid ones, no problem. Light wheel assets are amazing. Nobody ever gets to this point in the video, so I don't have to worry about anybody actually hearing this stuff. But I do like, let's see that it has it right there. Now, why does it let it go? And then squishes it again. Yeah, that's dumb. Don't understand. So I'm going to figure that out. All right, but I think we have one success, one failure. Stop the video there and push that.